Hi, my name is Ryan. I'm a big data developer at Talend. I joined Talend about 5 years ago to work on one of their flagship products, which is the Talend Studio. It's something that developers used at the time to write single JVM jobs in a visual environment. So we provided a visual language where you'd click through the configuration and run your job, generate Java code, compile, run your job. So about 5 years ago, we started a massive rewrite to have this run MapReduce jobs. So MapReduce was not new 5 years ago, but we were about ready. The customers were about ready to have, the customers that used a visual environment were ready to start generating, submitting, and running MapReduce code. So soon after that, of course, once the big data developers, who are the big data analysts and operators, they were excited to see Spark code. So we rewrote for Spark code. And then we did a proof of concept for Tez, and we did a tech preview for Storm, which was short-lived. It didn't really get the traction we wanted, and of course, we did not have enough developers and resources to do our massive rewrite in Spark streaming. You can really see that why Talend is excited to be moving to Beam for its new products. We just do not have enough resources to support all the execution environments. So the new product, I'm going to go through this quickly. This is another intro to Beam. So the things you have in common when you're constructing a pipeline is typically you have the markers that are distributed data. So at that point, they're just bookmarks, and you have them adapted by configurable, by distributed work. So in Beam, the distributed work are P transforms, and the distributed data are P values, but typically we say P collections, the ones we use most. So when you're constructing your pipeline, whether in a visual designer or in an IDE, you're writing all of these things. At that point, your distributed work had better be fully configured so it can be shipped off to the node, but the distributed data, when you're constructing your pipeline, are just bookmarks so that the runners underneath can make decisions about how to materialize, partition, how to serialize all the distributed data when the job is running. So the nice thing about this is it's a good abstraction for all of the execution frameworks, but it's also a good mental model. So this is the Talend Pipeline Designer. It was demoed as data streams in Beam 2018. It went into production in spring this year. So it's a visual designer in the cloud to do job construction and design. And you can see the programming model of Beam maps really nicely to the mental model a user, an operator will use to construct a job, where you've got components on the screen that represent the distributed work that had better be configured by the time you click the run button up top, but you also have on the links the distributed data. So my talk today is, how can we use this distributed data to make constructing your pipeline easier? So, you can't really see that very well, unfortunately. But I've selected one of the components up top. It's a Python code. We're going to do a Python transformation on distributed data. And on the bottom, you can see a list of the records that are incoming. So this is real data coming in. A list of the records, a sample of the list of the records that are incoming to the transformation. You have your Python code here on my left, your right. And once you've saved, you can see the records coming out of that particular transformation. So this is during the design phase before you've clicked run up top. And you can also see there's a sneaky arrow, this preview data at the bottom. There's a sneaky arrow going from the preview data over to the configuration. Because we have a widget here for writing Python, we have the schema of the incoming data right here, right in front of our eyes. And we can use the schema data to fill in the autocomplete information in the Python code. Oh, is that better? So that's something that's quite interesting for us to do. And my talk is, how did we get this distributed data into the system? What did we need? What are the lessons learned so that other Beam tooling can use the same techniques? And also we've got call to actions to say, hey, if you're writing a Beam IO, this is what you can do to make this type of tooling easier. So moving on, we say you click on a component, you want to configure your component. I'm not going to go through all the lessons learned and all through the calls to action, we just don't have enough time, but what makes an effective UI to configure your component? There's some standard UX things. Users love choice boxes as opposed to text fields, and users really, really love when you've got complicated things to fill in, they like autocomplete. So that's super interesting. The call to action is, if you're writing a Beam component and you're exposing knobs to configure your Beam component, if you can, make sure we have the information that we can fill in these checkboxes and these choice boxes and autocomplete. Some of them are obvious, like if you're writing a Kafka I/O and you have the starting offsets, you give us an enum to say, well, the valid starting offsets are earliest or latest. Some of them are not very obvious. If you're writing a Kafka I/O and you're saying with topics, we would love for you to give us a method saying, given the configuration for the brokers and the ports we have already, these are the topics that are available. Now, this is sort of a controversial ask because that's something that you do not need in a full run. But I think there's a good case to say if you do provide it, it will be used by people writing Beam tooling. And Beam tooling is great for everyone. Beam tooling grows the community, it grows usage of Beam. So your pull request, you might get someone saying, you don't need this method. You can argue back, well, some people do. It's useful. Moving on, I wanted to talk about data exploration. So if you have a fully configured, in the job graph, in the IDE, you've got a fully configured P-transform that gives you records. What can you do with it? Well, it's easy enough for us to say we've got this fully configured P-transform. We're just going to pluck it out of the job that you're actually running, and we're going to put data quality and data quality and exploration transformations after it and run it. And we'll just put them in a UI. There we've got in the Talend Pipeline Designer, we have the UI with a list of records that we discovered, and you can see there's some semantic analysis and some data cleanliness analysis up there. It's really quite a huge subject. I'm not going to go into it much more because what actually happened, it's such a huge subject, it got spun off into a different product and a different team. One of the things we did learn, however, is that if you're getting a sample, if you're getting preview data, the users want to do one of two things. They're either filling out their form for the distributed work, and they want you to just check, did I fill that out correctly? In that case, any data will do. They just want to see what's coming back, and they can do a tiny bit of exploration. Hey, I see I've got these fields. Or they actually want to do relative metrics on exploration. So the second subject's a huge one. The second subject, relative metrics, you really need a lot of work behind it. The first one is simple, but still really helpful to a user developing a job. Call to action for streaming. Make sure you've got stopping conditions so that we can do a sample out. That's actually quite important. So talking about sampling, when you're getting records for data exploration, in some cases, you do want to do real data exploration. In that case, getting the data will take as long as it takes. Now, it's important for the user that it comes back quickly, and we found that a lot of the data exploration techniques we use work just as well in a sample, which helps reduce the time to run the job. So in that case, you've got your P-transform that runs all of the records over all of the records. You just select some of them and bring them back. It takes as long as it takes. If you're doing just some confirmation feedback, does my P-transform work? Is it correctly configured? We want to do something much faster. So statistically relevant sampling is like going through all of the people in this room, scanning them and saying, giving each of them a random number and picking the 3 top random numbers. You've got a statistically random sample. And that's actually how the sample fixed size globally transformation works in Beam. But if you want to do something quicker, you've got opportunistic sampling, which is like saying, I'm just going to take these 2 people in the first row. That's good enough. So it's a bad sample, but it'll give you enough to say, yeah, my transformation's done correctly. So this is something that's quite complicated, doing opportunistic samples directly on a Beam I/O that has been configured to return potentially billions of records. Lessons learned, see what the user wants to do, make sure you're doing what the user wants to do in that context. And the call for action is, again, stopping conditions are important, especially for streaming NOAC. So if you have a streaming input, please provide a way for us to say, we would like to get some records, but not consume them because users don't like it when their full run jobs lose records because we did a sample behind the scenes. I'm going to give a case study, the JDBC.io. Now this case study here is something that we used quite early from Beam. I think it appeared in one of the first incubating releases of Beam. It's still there today, of course. This is the old version of Beam.io. So this is when we started working with it. We found that the Beam.io underneath the P-transform, it does this work here. It creates a single partition with a single value in it, a string value that represents a query. It gives that query to a doFn, which runs because it's a single value, it's a single partition, it'll run the doFn, go to JDBC, get all of the records and spew them out. And because that's not very big data at all, it does a reshuffle to make sure that the data is correctly partitioned among the potential partitions for the next operations to proceed. Now, this is excellent for a full run. This is excellent if you've got a lot of data. It's a good technique. But, however, when you want to take a fully configured P transform and get a quota, a certain number of records out of it, it's really tricky. Now, there are 3 reasons. The first is the initial implementation didn't let us set the fetch size. Now, with the JDBC drivers, some of them behaved correctly or wisely, some of them didn't. Some of them, in fact, in MySQL in particular, would crash just before the read FN when it did the execution because the fetch size wasn't set. So it would try to read all the records into memory, and it would just bust right there. So before even emitting a single one. That was fixed about a year ago. So next problem was you've got the fetch size correctly done. You're spewing records. You're going to scan over the entire P collection no matter what happens, because all of the actions taking place inside a single do-FN. This is a bit problematic because there's no way to say, I'd like to stop now, short of rewriting the query. So you've got a fully configured P collection. You have to change it so that you can get an opportunistic sample. This was actually recently corrected. They had the same use case for other reasons, where the shuffle in the JDBC I/O is now optional. So that's great news, because it was completely useless for us, because we just wanted the data as quickly as possible, and that introduced latency and caused slow results for users. So this is kind of funny. The lessons learned, test everything. The limit keyword, if you're rewriting it, I don't know who is reading the SQL sample, but it's not the JDBC implementers. The SQL standard. Everyone implements the limit differently. Call to action. There's something up there interesting saying we want to be able to configure for batch size. That's kind of funny because there was Alexi who not 5 minutes ago tells us don't bother giving a knob to configure for batch size. And we work 5 meters apart. So I'm here to tell you, give us a knob to configure batch size. It's important for streaming, or sampling. So that's one of the great things about having a community is we can have different opinions and different perspectives. So that's where I'm right and Alexi's wrong. No, seriously, what he's speaking about, it's a slightly different thing. It's write batch sizes and read batch sizes. Read batch sizes or fetch sizes are important to be configurable. So the good news in 2019, the JDBC I/O is in great state. Thanks, Beam community, you're doing an excellent job. So this is another funny thing. I promise I didn't write my slide after, but we had from Kettle, they mentioned Salesforce. Now Salesforce is what would you say, an enterprise customer success software as a service layer where you can store data about accounts and leads. It's very enterprisey, probably doesn't have a place. The Salesforce I/O probably doesn't have a place in the Beam repository because it's something that's inherently small data. You can have millions of records in a Salesforce database, but you can't export more than, to integrate into a job, thousands. We'll say it's small, it's inherently small data. It's typically used for things like join tables, enriching data, and ingestion. Or using intermediate results, if you're looking for the top 10 accounts, using that in your Beam pipeline. So in this case, we had something already, the small data, we had something already which is pretty much an enriched iterator that went over Salesforce data. It had all of the glue code already to do the forms, to do the forms for exploration, and we just took our iterator, stuck it inside a source, and thanks for Alexi for explaining what is a source, and we can iterate over that source and use it inside the read from as a P transform. So there we have the internal use of Salesforce now plugged into a Salesforce I/O for anyone to use. Now this is open source. This is the Salesforce I/O is available in the Talend repositories. One of the interesting things I think you might have seen earlier that I miss bounded source. There was a choice in the Beam community to only base on P transforms, which gives you a really nice unified experience. Bounded source is really nice for people like us who are doing something a bit weird because you can just stop asking for data. So instead of using the bounded source over an iterator, you can use my bounded source with sample where I'm going to read next. I've got my 10 records, done. So that's good for us. Okay, going to a quick demo so you can see some of the things we're talking about. This is the main Pipeline Designer user interface. We have our business logic separated into connections, data sets, and pipelines. So that's, how do you get to the persistence layer? In Kafka, it would be brokers and ports. And how do you get to a collection of records? In Kafka, that would be a topic. And finally, how do you want to read or write to those? Let's just pick a demo here. We've got S3 with the form. I just wanted to show you the form. There we go. One of the actions we exposed in the form, which you don't need for a full run, but you do use, is just to check the connection. So you can just click on that. The S3 IO we have will pop up. Did it pop up? There it is. It'll pop up that I've correctly configured my form. So this is important as part of a good user experience. You want to show everything's good. You're doing well. Going to the data set, I'm going to use the taxi demo. That's sort of the new hello world count. And I've configured it. I'm not going to go through the configuration form to point to the bucket with an autocomplete on the list of buckets. So we can see all of the records in the taxi demo and some of the semantic analysis. You can see that the first one, vendor ID, was detected as an airport code, which it's not, so it's a bad semantic analysis. But if it were an airport code, you could see 50% of the records are wrong. They're invalid values. And going on from the taxi demo right to a pipeline, a job that I've constructed. I've pre-warmed everything up, by the way, just to make sure that this is fast. You can see we've got the graph, the job graph we want to do. We've got the incoming records from the taxi demo. Take a quick look at the hierarchical structure of the incoming records. Information going through. I'll click right on aggregate back there afterwards, where we're taking some of the data we've extracted so far. We're going to calculate 3 aggregates on it. So you can see I'm going through the passenger count, the number of passengers versus the average cost per kilometer, but also the maximum cost per kilometer and the minimum cost per kilometer. So the configuration on the right makes it very easy. Instead of doing the minimum cost per kilometer, I'm going to say, how many kilometers have they run? So we're clicking on save. It will just get the output. We'll get the new update. There's 28 kilometers for the passenger count of 1. So 28 is not a lot. You can see we're operating on the sample here. But what if we really want to do the full run? There's just the run button up top. I'm just going to click that and it's going to run. We won't have enough time to see it succeed, but you can ask me afterwards. One of the interesting things here is that you can see we're submitting the job to Databricks. Now, all of the configuration for Databricks and the Databricks managed cluster is hidden from the operator at the pipeline. There's someone else who takes care of it. There's an administrator role who has completely configured the how to submit correctly to Databricks. And the job has been submitted. I'm not going to go to Databricks to see it. We'll just go straight on to conclusions. In conclusion, some of the lessons we've learned. Number one, it's pretty easy. Any UX developer will tell you, love your user, give them good options, guide them along the way while they're using your tool. For the lessons learned as well for us, or sort of a call to action, what would we like Beam.io writers to do? Well, think about this use case, getting the grab sample, the opportunistic sample from your Beam.io. It's a pretty interesting use case and can lead to other tools that are interesting as well. And finally, if you're a developer developing a Beam tool, always keep your eye on the community. There's some really great things coming. We've seen the schema-aware P collections. That's going to be completely awesome for us. So we're not currently using them, but if you look at what we're doing in our UI, it fits super well. As well, we've got inside Talend, a lot of work, inside and outside Talend, a lot of work on the Spark runner and running data frames that are aware of the schema P collections, which will also be able to help us integrate with Spark tools. So that's really going to be quite exciting. Okay, so that's the finish. That's the end of my presentation. Are there any questions?
Thank you so much, Ryan, for this session. I would like to give you the chance to ask a few questions. Raise your hand if you have a question over there.
Thank you, Ryan. Just a small remark. So I was talking about not to use all these batch sizes configuration if it's possible. In your case, it's your case. It's exception. Thank
I
you.
agree. I think there's a really good purpose to minimize surface area of the API. That's a really admirable goal, but not to exclude use cases because you think you can minimize it further.
Sure.
All right, we have time for one last question. Anyone? All right, well, thank you so much, Ryan.